All right, let's take a look at the concepts of a slope of a curve at a point. Let's look at the slope of a curve at a point. So here's what we're looking at here in this particular section then, right? So let's suppose you have the graph of some function, right? Let's say the graph looks something like this, all right? And we want to find out, okay, well, suppose at this point right here, at this particular point right here, right, on the function f of x, right? We want to know, okay, well, what is the slope of that curve at this particular point? The way we can find that is we look at the slope of a tangent line at that point. Now, what a tangent line is a line that's touching that's on that point, but it expands out. It just touches the function graph at that particular point. So let me go ahead and let me see here. Let me draw that. So here's the tangent line, for example, right? So this would be the tangent line. Tangent line at, let's say this point is point P, this point right here, right? So at P, all right. So this is the so that's what we want to we want to be able to find the equation of this tangent line, and we want to calculate the slope of that point, uh, of a slope of that curve at that particular point, right? So that's the main concept. So let's look at some of the problems on the homework on this then, right? So let's take a look at this here. All right, so for example, let's take a look at number 2 here, right? So let me take a screenshot of that. Bigger. All right, so consider this problem on the homework here. So what you're asked to do here is to estimate the slope of each of the following curves at the designated point P, right? So find the slope of this tangent line, right? So and this tangent line happens to be a horizontal line. Right? That's important in calculus, right? The horizontal tangent lines has certain implications, right? So let's take a look at the slope of this. Well, then clearly, since it's horizontal, right? Then clearly that m, the slope, is going to be zero, right? Remember, the slopes of horizontal lines is equal to zero. All right, so we're okay on that, right? So if we didn't know that, then we could pick out well, in this case, the slope of the horizontal line is going to be zero. But if we didn't know that, we would have to pick out a couple of points on this tangent line and find the slope, right? Because you need 2 points to calculate the slope, right? But for horizontal line, um, it's gonna be zero in terms of the slope. All right. Let's look at one where it's not zero though. So let's try this one. Let's look at number 4, for example, right? So here's where we have a diagonal line, right? So let's look at this one here. Excuse me. All right, so let's look at this problem. All right, so on number 4, here's a diagonal line at this point P here, right? Now, none of these grids are labeled, so we can assume that they're 1 unit each, right? So, but here's point P right here, right? This is point P. All right. Now, how will we calculate the slope at that point then, since we don't have any numbers here, right? Well, we don't really need any numbers here, but what we need to do is pick out 2 points, as I was saying earlier, right, on this tangent line, right? So let's pick out, and you can pick out any point you want, but on the tangent line. But here's one I can see clearly. Let me see if I can, um, you know what? Let me do this. Let me make it bigger and see if I could. Let me see if I could make the graphic bigger so you can really see. I think that's pretty big there. I'm gonna cover up some of the notes here, but hopefully we're good on that. All right. But yeah, so again, here's my point P, right? So we can use this point P, which is fine, right? Or we can use and what else? Or we can use the point down here, right? Any of these 3 points is good, right? So take your pick, right? Because they're all on the same line, right? On the same tangent line, right? But here it is, right? How do you go from point P, for example, to this point right here on this grid? Well, you're going to go one up, right? You're going to go one up and one to the right, right? One up, one right. And to go from point P to this point right here on the tangent line. So if you remember slope, right? Slope is what? Rise over run, right? So if you go one up, that's one on the rise, one to the right, that's one on the run. So the slope is going to be one. Can we see that? So the slope of the tangent line at point P is going to be one. Can we see that? Are you with me on that? All right. Let's try another one here. Let's take a look at the so that's the main concept, right? Be able to find the slope of the tangent line at a particular point on the curve, right? Look at number 8, for example. Let's try this one here. All right. Let me see. It's the same. Okay, it's the same type problem. Let me go ahead and take a screenshot of it for you then. All right. Let me see if I could. Let's see. I'm gonna clear out the screen, guys. Let me make it real big so we can see it much better. Okay. I think that's pretty good. All right. So take a look at this point here. So there's the tangent line right here, right? At this particular point P. Right. Again, pick out 2 points on there. So we use P as one of the points. Now the next point I can see clearly is going to be point down here or the point up here. Take your pick. It doesn't matter. I'll use the point down here. So how do you go from, again, pick out 2 points on the tangent line, right? So these are the 2 points I'm going to pick out. Point P, obviously, since the tangent line goes through that point on this particular curve. This is our function here, right? All right. So how do I find the slope of this tangent line? Well, again, how do you go from point P to this point here? You're going to go one down, right? And what? 1, 2, 3, 3 to the right. We see that rise over run in terms of vertical change and horizontal change. From P to this point here, it's one down, 3 to the right. And we see that. So the slope is going to be negative because you go one down, right? Negative 1/3. And we see that slope is going to be negative 1/3 of this tangent line. Are you with me on that? All right. Let's go ahead and try another one here. Let's look at number, for example, how about number 20 here? Number 20 here and go back up here. Okay, so in exercise 13 to 20, let me just take a screenshot here. Let me see if I yeah, let me just screenshot these set of problems here. Let me see. I'm gonna screenshot here. Let me take a screenshot of these problems. Not too bad a concept here, so let me clear this out. Nice and big here so you can see it clearly. All right, so let's look at number 20. All right, so it says find the equation of tangent line, right? To y equals x squared at the point where x is equal to let me roll over that negative. Sorry, 2.1. Right. So here's the curve. That's just the parabola, right? That opens up with vertex at the origin, if you recall from algebra, for example, right? But we want to find the slope, the equation of the tangent line at that x coordinate, right? So what you need to do then is you need to figure out. You don't have to graph it, though you can, right? But what you need to do is figure out what point that is, right? So if x or y is equal to x squared, right? You're told that x is equal to 2.1. That's our x coordinate, right? At this point where the x coordinate, right? At the point where the x coordinate is 2.1. Let's plug that in. So we're gonna get y equal to 2.1 squared, basically, right? 2.1 squared. Now, what is that? Let me just punch that to the calculator real quick. I'll bring up my virtual TI. All right. So 2.1 squared will be 4.41. So the point we're talking about, P, is 2.1, 4.41 on this curve right here, right? This curve, we'll say it's the same thing, x squared. All right, so we're good on that. So that's our point. And this point is going to be on our tangent line. So all we got to do now is figure out the slope of the tangent line, right? What is the slope of the tangent line? This is number 20 here. Right, what's the slope of the tangent line? Well, if you look at the, let me go to your text here. We're going to find this slope using derivatives in the next section, but take a look at the formula that they have for us here. Let me follow along on my text on the textbook here, right? But you're gonna see that here it is, slope formulas, right? The slope of the graph of y equals x squared at the point, notice at any point, right, on this curve, on this parabola, is gonna be what, 2x, okay? So it's gonna be 2x. So that there's your slope formula, right? So the slope, go back to the problem here. So the slope is equal to 2x when we're talking about the parabola x squared, y equals x squared. So that's the slope formula for this parabola for x squared. So the slope is going to be what? Well, x is what? X is 2.1, right? That's our x, right? So this is going to be 2 times 2.1, which is 4.2, right? You just punch out the calculator, right? So we're good on that. So the slope is 4.2. So there you have it. You got the slope, you got the point on this parabola. Now, your book gives the equation in terms of the point slope formula. I would have preferred them to use the mx plus b, right? Again, the preferred equation format is y equal to mx plus b, right? But your book gives the answer as the point slope equation of a line. And what that is if you're given a point x1, y1, and you're given the slope of the line m, all right, slope, right? Then the point slope equation is going to be y minus y1 equal to m times x minus x1. And this is the point slope formula. So our answer is going to be using this format. Then again, I would prefer mx plus b, but unfortunately your book doesn't give you that answer. It gives you the point slope equation of the line, of the tangent line, that's right. In this case, the tangent line. So there we have x1, y1, right? There's my point, 2.1, 4.41 for the y coordinate, and we have the slope, m. So there it is, y minus 4.41 equal to m, 4.2, times x minus 2.1. That's it. So this is the point slope equation that your book wants you to have for the final answer. It says, what is it? Sorry, find the equation of the tangent line. All right. So using the point slope equation. Again, I would prefer the slope intercept equation, but that's what your book wants. All right. Not too bad at all. Let's just try another one here. Let's look at number 24. All right. So I'm gonna slide my calculator away for right now. Give myself some space here. Let's do 24. Move my calculator over there. All right. So 24. Right. Find the point of the, again, same, find the point on the graph of this parabola, right? Y x, where the tangent line is parallel to the line 3x minus 2y equals 2. So parallel to, E right there, sorry for my handwriting, parallel to what, 3x minus 2y equal to 2. All right. Now, remember from algebra again, parallel lines have the same slope. So we just have to find the slope of this line. All right. And you can get an mx plus b, speaking of that, right? Solve for y. Subtract 3x on both sides. We're going to get negative 2y equal to negative 3x plus 2 and divide by negative 2. You with me on that? So we're going to get y equal to positive 3/2 x, right? Positive 3/2 x minus 1. We don't really need the minus 1 because the slope of this line is 3/2, and that's going to be the slope of our tangent line. Because we want the tangent line is parallel to this line, right? And so we have the slope, we just need a point. Well, the point is going to be what? Now, again, what is the slope of the what is the slope formula for this parabola again, right? Here it is, right? 2x, right? I showed you earlier on the text, right? So we just need to set this. Now, our tangent line is going to have this slope 3/2. So what we need to do is what? Find the x coordinate that will give us that 3/2, right? For the slope, right? In terms of tangent line, because it's parallel to we want to parallel to this given line. So just set this 2x formula to the 3/2 and solve it to get the x coordinate. So let's multiply both sides by 1/2. Just some standard algebra there. So x is going to be what? 3/4. right? 2 times 2, 4, right? So x coordinate is going to be 3/4. Now, what's the y coordinate going to be? Well, we know the y coordinate is x squared, right? I'm going to scroll down just a little bit, guys. So y is going to be x squared. So y equals x squared, which means that you're going to get 3/4 squared, right? Because x is 3/4. That's going to be what? 9/16. So it says find the point on the graph of this parabola where the tangent line is parallel to this line is going to be at the point 3/4, 3/4, comma 9/16. That's the point we're looking at on this parabola that will have a tangent line whose slope is going to be 3/2, which means it's parallel to this given line. Does that make sense? Can we see that? All right, let's do a couple more here. Let me scroll down just a little bit. Let's look at number 30. All right, so here it is. Let me take a screenshot of I think I'll do okay, I'll screenshot this part here. I'll screenshot this part. We're gonna look at number 30. Let me clear this out. All right, so let's look at number 30. All right. In case you can't see it clearly on my screenshot, this point is 3/2, 27/8. All right, that's the point. But what does it say here? It says in the next section, we shall see that the tangent line to the graph of y equals x cubed. This is the x cubed graph. Right? Again, we'll look at derivatives to get this 3x squared in a moment. But the slope formula for that, unlike the x squared graph, right? So for when y is equal to x squared, the slope formula is 2x, right? When y is x cubed, the slope formula is what? 3x squared. That's what we're being told has slope 3x squared. Right, use this result to find the slope of the curve at the points. Okay, so find the slope of the tangent line, right, to this point, for example, right. So just plug it in, really, right. So m. So we don't really need the it's 3x squared, so we don't need the y coordinate, right. So therefore, the slope at this point on this curve is going to be 3x squared, which is 3 times my x. This is my x right here, 3/2. 3/2 squared. Are you with me on that? So this is going to be 3 times, what is that, 9/4, right? 3/2 squared, which is what, 27/4. So that's the slope of the tangent line at this point on this x cube curve. This is the x cube graph, right? Okay, so again, we'll figure out the slope formulas in general when we look at derivatives here. All right, let's do one more. Let's look at number 36. Let me take a screenshot here. Let's see, where's figure 15? Okay, this is figure 15. Okay, so I'm just gonna screenshot 36 then because it's related to that figure. So let me screenshot 36 right here. Put it right here. Let's look at 36 here, all right? So find the points on the graph in figure, so in this x cubed curve, right? This is figure 15 here, right? So where the tangent line is parallel to 2x. It's very similar to what we just did with the x squared graph, right? Parallel to that 3x minus 2y equal to 5, I believe, right? So let's look at, well, the slope here is going to be 2, right? 2x, right? So m is going to be 2. So we want the slope to equal to 2, right? So again, what is the slope formula for the x cube graph? Here it is, 3x squared. So just set 3x squared equal to 2 and solve for x to find the x coordinates on this curve that will have the slope of 2, because I'm setting the slope equal to 2, right? Are you with me on that? So let's divide both sides by 3, right? So we're going to get x squared equal to 2/3, right? Take the square root of both sides. So we call some algebra on equation solving here. So we're going to get x equal to, now when you square root both sides on for x squared, you got to get a positive root and a negative root. So plus or minus, I'll break it up, root 2 over root 3. Break it up into numerator and denominator for square roots. And we should rationalize this this square root on the denominator, but I'm not going to do that yet. I'm just going to because basically we're asked to find the points on this curve, right? And remember, the curve here is x cubed, right? So let's just plug it in like this, right? And then we'll rationalize or get rid of the square root at the end, right? So let's look at the positive one, right? When x is equal to positive root 2 over root 3, what's y going to be? Well, just cube it, right? That's going to be root 2 over root 3 cubed. All right, are you with me on that? All right. And this is going to be what? What's first of all? Let's look at this on the side. Some side work here. Let's look at root 2 cubed. This is root 2 times root 2 times root 2, right? Which is root 8. Square root of 8, right? Now, if I simplify that, I will get what? That's 4 times 2, so 2 root 2. So we call how to simplify square roots in algebra. So root 2 cubed is going to be 2 root 2. All right, are you with me on that? All right. Now, what about the root 3 cubed? Well, that's going to be root 27, right? Right, square root of 27. Gonna be very similar logic. Replace the 2 with the 3, right? 3 times 3 times 3, wouldn't that be 27? So this is going to be root 27. Again, that's 9 times 3. So this is going to simplify to 3 root 3. Because root 9 is 3. 3 can come outside the square root. So we call it to simplify that, right? Now, again, so my answer is going to be what? For that point, it's going to be root 2 over root 3 for x, right? And then root 2 over 3 root 3 for the y coordinate. Now, we don't want to leave our answer like that because it's algebraic convention to get rid of the square roots on the denominator. So let me show you some additional algebra on the side here. So let's look at root 2 over root 3. We're going to multiply by root 3, if you recall from algebra, to get rid of the square root. This will give me root 6, right? 2 and 3, square root of 6 over 3. Root 3 times itself is just basically square, so it gets rid of the square root. So you get 3. So this is going to be root 6 over 3. You with me on that? What about same thing for root 2? I'll show you the work here. 2 root 2 and 3 root 3, right? Let's multiply by root 3 again. Very similar, right? Top and bottom to get rid of the square root 3 on the bottom. So you're going to get 2 root 6 now, right? Sorry to squeeze all that work on you here. Are you with me on that? Right? Because that's a 2 right there. Sorry about that. 2 and 3, that's going to be 6 on the inside square root. And again, root 3 times root 3 is 3, right? So this is going to be 3 on the outside, and then you have this 3 here from the root 3 multiplying to itself. So that's going to be 9. Can we see that? So this is going to be 2 root 6 over 9. Are you with me on that? So that's the final answer in terms of getting rid of the square roots on the denominator. All right, that's for x being positive 2 root 3. What if x is negative, right? Because plus or minus, right? Well, if it's negative, then basically you're just going to, since you're cubing it, right? So here, I'll show you a little bit of work here. Let me see if I'm gonna scroll down just a little bit to free up more space. All right. So let's look at x being negative square root of 2 over square root of 3, right? Plus or minus the negative case, right? So that means y is going to be negative root 2 over root 3 cubed, right? Because the equation is y equals x cubed. That's the curve here, right? So I need to find the xy coordinate on that curve. So this is just plugging in a lot of this, right? But again, we did most of the work in the previous one, right? The only thing is what? When you cube this, it's a negative number. When you cube a negative number, it's going to stay negative. Are you with me on that? So therefore, it's the same answer as this one, except that both the x and the y coordinates will be what? Negative. You see that? So it's the same work, same algebra, so I'm not going to rehash it, but you're going to get negative root 6 over 3 for the x coordinate. Again, you can, just multiply by root 3, but it's negative, right? So that's why you get the negative there. Again, when you cube a negative number, it stays negative. So this is going to be the same number, except it's negative. So negative 2 root 6 over 9. All right, are you with me on that? So this will be the 2 points on this curve, on this x cubed curve, that will have a slope of what? 2. Slope of 2. Okay, so we're okay on that. All right, so again, the slope formula for the x cubed is going to be 3x squared. Again, let me scroll up just a little bit. Oh, in fact, it tells you that I don't have to. It tells you your slope is 3x squared, right? So it tells you that. All right. So until next time, then. Thank you.